The success of large language model is often attributed to in-context learning. There are different prompt engineering techniques which are used for in-context learning. In our last lessons, we talked about zero shot, one shot and few shot prompt techniques. In this video, we are going to talk about another very important prompt engineering technique called chain of thought. If you are new to prompt engineering, I recommend you to watch the previous lessons before continuing this lesson, which is about chain of thought prompting. Let us explore the concept of chain of thought by examining our own thought process when solving a multi-step math word problem. So this is our problem statement. For humans, it is natural to break down such problems into intermediate steps and solve each step before arriving at the final answer. So the step-by-step solution looks like this. So there are originally 15 trees. After planting, there are 21 trees. Therefore, the number of trees planted today is 21 minus 15 equals 6. This step-by-step process forms a chain of thought which humans intuitively create while solving such problems. Similarly, sufficiently large language models can generate chains of thought if examples of chain of thought reasoning are provided in the prompt. This allows the model to break down complex reasoning problems into simpler steps, improving its problem-solving abilities. How to enable the reasoning abilities in the language model? In 2023, some researchers published this two paper which mainly talks about how to enable the reasoning ability in the language model in zero shot and few shot prompt technique by just adding some additional instructions for chain of thought. Let us have a look at some examples how to unlock the reasoning ability in the language models through chain of thought prompt technique. In the last lesson, which was on few shot prompt technique, I demonstrated a use case where few shot prompt was not good enough and we ended up switching to a bigger model to achieve the task in hand. Remember that task was to reverse the word. But switching to a better model is not that easy because if you are working on on-prem environment, then there are hardware constraints to host such bigger model. And if you are working through commercial LLM providers, then better models are always expensive. Moreover, scaling up model size alone has not proved sufficient for achieving high performance on challenging tasks such as arithmetic, which is math word problems, common sense problems, and symbolic reasoning. These tasks requires reasoning abilities. This is the Jupyter notebook I'm going to use for this lesson. Now, first we need to create the setup. So let's install OpenAI libraries. Now let us import OpenAI libraries. This code retrieves our OpenAI API key from Google Colab storage, which is this Google Colab secrets where I have configured my OpenAI API key. And then this part of the code creates a client object to interact with OpenAI API. Let's initialize this. This code defines a helper function called getResponse that takes a list called messages which holds the prompt instructions and user data. Inside the function, it uses the client object to call the chat.completions.create function of the OpenAI API. This function generates a response based on the provided messages and the specified model. Here we are using GPT 3.5 Turbo. The temperature is set to 0, indicating a deterministic response. Finally, the function returns only the content of the first generated choice from the OpenAI API response. So let us initialize this function. In the first example, the task is to concatenate the last letters of a word. Now here the word is Amy Brown. Looking at this task, it appears that it falls under symbolic reasoning tasks. For demonstration, first we shall try zero shot without chain of thought. So here, this is our zero shot prompt where we are saying concatenate the last letters of the word Amy Brown. So in the messages list, we are appending this user message and we are calling our getResponse function. So let us run this. Now, the response is not correct, because if we concatenate the last letters of this word Amy Brown, then it has to be Y and N. And this is obvious because the task was kind of a reasoning task, and we have not yet enabled the reasoning ability of the model. Now, to enable the reasoning ability of the model, we need to add the chain of thoughts instruction in the zero shot prompt. So now let us enhance our zero shot prompt with chain of thought. Now, so this is our original instruction. In this instruction, we have added this additional prompt which says, let's think step by step. For zero shot prompting, such a statement is enough to enable the reasoning ability of the language model. So now let us run this. Now this time you see, when we enable the reasoning ability of the model, it's saying that the last letter of Amy is Y and the last letter of Brown is N. Therefore, when we concatenate the last letters of the word Amy Brown, we get YN. Perfect. So we were able to enable the reasoning ability of the model in the zero shot prompt technique through chain of thought. Now, let's take another example where we should learn enabling reasoning ability in language model through few shot. Here, task is to reverse the word lollipop. So we are first going to implement this use case through zero shot, and if we are not able to achieve the desired result, then we will move to few shot. If few shot is also not sufficient, then we will try to add chain of thought in zero shot, and if that is also not sufficient, then we can add chain of thought in few shot. Looking at this task, it is obvious that this task requires reasoning ability of the language model. So we could have directly attempted using zero shot with COT or few shot with COT. But just for demonstration, I'm going to go in this flow. So I'm going to see if zero shot alone is sufficient. If not, then move to few shot. If not, then move to zero shot with COT, and finally few shot with COT. So let us try zero shot. Now here is the task instruction. Reverse this word lollipop. So in our messages list, we have appended this user prompt, and now we are calling this get response function, passing this message list. So let us see what is the response from the model. We can clearly see that this response is incorrect. So the language model was not able to reverse this string lollipop through zero shot prompt. And it was also expected because we have not yet enabled the reasoning ability of the model. Anyways, let us try with few shot. So this is our few shot instructions. So here we are saying your task is to reverse the word, and we are providing few examples. And then finally, we are asking the model to reverse this word lollipop. So let us initialize this prompt instruction and append this system prompt and user prompt in our messages list, and then call get response function, and let us see the model response. We can still see that the response is incorrect. It is again obvious because we have not yet tried enabling the chain of thought capability of the model or the reasoning capability of the model. Now let us enable the reasoning ability in zero shot through chain of thought. So to do that, in our original prompt instructions, like reverse this word lollipop, we have now added this additional string, which is let's think step by step. And this string will help to enable the reasoning ability of this model. So let us run this. This response is still not correct. So we can say that zero shot with chain of thought was also not successful for this problem. So let us try to enable the chain of thought through few shot prompting. So in our original prompt instructions for the few shot, we are going to now modify that. And what is the modification we are going to do? We are going to add these strings. The first is let's think step by step as shown in below examples. And in the examples, like the first example, we are going to provide the solution steps, like step by step how you can break this problem and try to arrive at the right answer. Similarly, for the second example, we have provided the step-by-step solution. And also for the third example, we have added this step-by-step solution. And finally, we will ask reverse this word lollipop. And let us see if now it is able to do it. So we have initialized our prompt instructions, and now we are adding the system prompt and the user prompt in our messages list, and we are calling our get response function. Brilliant. So now we can see that with zero shot COT, it was unable to do it, but with few shot COT, it is able to deduce the right solution. So this is how we need to think about the task in hand and see what kind of task it is. And if we realize that we need to enable the reasoning ability of the model to solve such tasks, then we should just do this hit and trial, try with zero shot and try to enable your chain of thought in zero shot. And if that is also not possible, then you can try to enable chain of thought through few shot prompting. So it's kind of an iterative process. So you have to try multiple iteration, multiple options, and see which one is giving you the right result. Let us take another example. Here, the task is to determine if the student's solution is correct or not. And here is the problem statement. So basically, the use case is that for a math problem, there is a solution provided by the user. Now, the task of the language model is to evaluate if this student solution is correct or not. Now, let us initialize this prompt. And now in the messages list, we are appending the system and the user prompt and calling our get response function to see if the model is able to verify the user solution. Now here model is saying the student's solution is correct. But if you manually try to verify this, you will notice that there was an error. Here in step 3, we can notice that student have made a mistake. Here, student have captured for the maintenance cost 100K plus 100 times. But in the problem statement, if you notice, the maintenance cost was 100K per year, a flat, plus additional 10 per square feet. But when he was writing the solution, he has captured this 100K correctly, but instead of $10 per square feet, he has captured $100 per square feet, and therefore the final answer is incorrect. So if you notice why the model went wrong, this is mainly because this problem was of reasoning type, and so far we have not tried enabling the reasoning ability of the model. Now, what we will do, we will try to enable the reasoning ability of the model. Now, in such kind of a problem, how to enable the reasoning ability? The one way of doing that is to ask the model that first work out your own solution to the problem. Then compare your solution to the student solution and evaluate if a student's solution is correct or not. Don't decide if the student's solution is correct until you have done the problem yourself. So this statement will force the model to enable its reasoning ability. And therefore, the model will try to first draft its own solution and then verify the user solution or the student solution with its own solution. So let us initialize this prompt and then append this prompt instructions into our messages list and then call get response function. Now we can see in the response that model is first trying to provide its own solution. And we can clearly see that at step 3, in model's solution, it has captured $10 per square feet, which is correct. And therefore, in the final cost, this is the right answer. Now, model will try to compare the student solution with this solution. So it is saying, therefore, the correct total cost for the first year of the operation as a function of the number of square feet is $360 times plus 100K. Now, let us compare the student solution to the correct solution. And then finally, it says that the student's solution is incorrect. Perfect. So we were able to enable the reasoning ability of the language model for this problem statement or for this task in hand with these statements. So far we have learned with a couple of examples, like what are all the task type where we should enable chain of thought in the model or the reasoning ability in the model. But if you have to put things together as a thumb rule or as a guideline that when to apply chain of thought, so chain of thought prompting can potentially be applied to any task for which humans uses a chain of thought to solve the problem. But still, there are these three key considerations one should have before applying chain of thought to the problem statement. With various research and experiments, it is concluded that chain of thought helps the most when three conditions are met. The number one, the task is challenging and requires multi-step reasoning. Number two, a large language model is used, because if you try to enable this chain of thought in the language model, which is less than 100 billion, the results are not impressive, and you may not be able to achieve the kind of a reasoning ability you are looking for in the language model. So if you're planning to apply chain of thought for your task at hand, then you also need to consider that your model size should be greater than or equal to 100 billion parameters. And third, when the scaling curve is relatively flat, it means that chain of thought reasoning helps the most in scenarios where simply making the model larger does not lead to potential improvements in the performance. In these cases, the model's ability to engage in multi-step reasoning or to think through a problem step by step becomes more valuable for tackling challenging tasks. Conversely, the benefits are smaller when one or more of these conditions are not met. Chain of thought prompting has several attractive properties as an approach for facilitating reasoning in the language models. So if we have to summarize the key properties of chain of thought, so here we can say that chain of thought prompting has several attractive properties as an approach for facilitating reasoning in the language models. First, chain of thought in principle allows the model to decompose multi-step problems into intermediate steps, which means that additional computation can be allocated to problems that require more reasoning steps. Second, a chain of thought provides an interpretable window into the behavior of the model, suggesting how it might have arrived at a particular answer by providing opportunities to debug where the reasoning path went wrong, although fully characterizing a model's computations that support an answer remains an open question. Third, chain of thought reasoning can be used for tasks such as math word problems, common sense reasoning, and symbolic manipulations, and is potentially applicable, at least in principle, to any task that humans can solve via language. Finally, chain of thought reasoning can be readily prompted in sufficiently large off-the-shelf language models simply by including examples of chain of thought sequences into the exemplars of few shot prompting, or just by adding let's think step by step in zero shot prompting. Now, one could ask that why chain of thought fails in small language models. The first observation is that small language models fail at even relatively easy symbol mapping tasks. The second observation is that small language models seem to have inherently weaker arithmetic abilities. The ability to do simple arithmetic operations without semantic understanding requires sufficient model scale. Finally, small language models often did not generate a final answer that could be constructed due to either repetitions or logic that never arrived at a final answer. In summary, the success of chain of thought reasoning as a result of model scale is a complicated phenomena that likely involves a variety of emergent abilities. Further work could more thoroughly investigated what properties of pre-training data, model architecture, and optimization objective casually enable such reasoning capabilities. In case you do not have access to bigger model and the only option you have is to fine tune a small model which is less than 100 billion parameter, then this paper talks about how to fine tune language model for reasoning ability. So you can have a look. This is all about this lesson. Thank you.